Almost everyone will eventually think about losing fat at some point in their life, and understanding how the body actually burns fat is far more interesting than most people realize. We often picture fat loss as fat simply disappearing from the body, as if it melts away. But the real process is far more complex and involves the coordinated work of hormones, enzymes, and multiple organs. To understand how our fat layer can go from several inches thick to just a few millimeters, it helps to explore what is happening inside the fat cells themselves and how the body moves and uses this stored energy. When most people talk about losing fat, they are referring to subcutaneous fat, the layer located directly under the skin. This is the tissue that hides muscle definition, whether it's the rectus abdominis or the deltoid. And for many people, the goal of fat loss is partly aesthetic. Reducing this layer makes muscle contours more visible. However, not all fat in the body is the same, and some types matter more for health. Visceral fat, which surrounds internal organs, is particularly significant. This type of fat accumulates deep within the abdominal cavity and around the heart and intestines. Unlike subcutaneous fat, high levels of visceral fat are strongly connected to metabolic syndrome, type 2 diabetes, high blood pressure, and several cardiovascular problems. Even though visceral fat is hidden inside the body, it can increase waist circumference as it expands, giving a rounded abdominal appearance. The good news is that the body loses visceral fat through the same fundamental mechanisms it uses to reduce subcutaneous fat. Fat loss always comes down to the movement of fat out of adipose cells and the use of that fat as fuel somewhere else in the body. To understand this process, imagine a situation where your quadriceps muscles are working during exercise and need additional energy. The body has the ability to pull stored fat from almost anywhere: abdominal fat, fat around the shoulders, or fat around the hips. If we zoom down to the level of the fatty tissue, we would see that adipose tissue is made of adipocytes, or fat cells, which store triglycerides. Triglycerides consist of a glycerol molecule attached to 3 fatty acid chains, and before the fat can be used as fuel, it must first be broken down. Inside adipose cells, the enzyme called hormone-sensitive lipase plays a central role. This enzyme needs activation, and exercise triggers the release of hormones such as epinephrine, norepinephrine, and cortisol, all of which help activate hormone-sensitive lipase. Once activated, lipolysis begins, meaning the triglycerides are broken apart so their fatty acids can be released into the bloodstream. Fatty acids do not travel easily in the blood because they are not water-soluble. Since the bloodstream is mostly water, the fatty acids must be transported by a protein. Albumin acts like a taxi for fatty acids, binding to them and carrying them throughout the bloodstream until they reach a tissue that needs energy. Once those fatty acids are circulating, some will enter the femoral artery and be delivered into the working quadriceps muscles. Inside the muscle fibers, fatty acids are taken up and shuttled into the mitochondria, the energy-producing centers of the cells. Using oxygen, the mitochondria convert fatty acids into ATP, the basic energy currency of the body. Fat metabolism is entirely aerobic, meaning it requires oxygen. Carbohydrates, on the other hand, can be used both aerobically and anaerobically, but fatty acids must have oxygen to be converted into energy. Although fats generate a very high amount of ATP per molecule, or more than glucose, they take longer to mobilize and use. It typically takes 10 to 20 minutes of continuous exercise before fat metabolism truly ramps up because of how many steps are required to break down and transport the fatty acids. Muscle cells also store limited amounts of fat, so the majority of usable fat must come from adipose tissue elsewhere in the body. In contrast, carbohydrates stored as glycogen are already conveniently inside the muscle and ready to be used almost instantly, which is why the body relies on them more during the initial phases of exercise or during high-intensity efforts. As the body continues to draw fatty acids out of adipose cells, the fat cells gradually shrink. This shrinking of the adipocytes thins out the fat layer and contributes directly to fat loss. The same mechanism applies to visceral fat. The body can pull fatty acids from around the organs just as easily as it does from under the skin. This leads many people to wonder whether they can choose where the fat loss comes from. Unfortunately, the answer is no. You cannot selectively burn fat from one region by exercising that specific area. Doing large numbers of crunches may strengthen the abdominal muscles, and those muscles may become slightly more visible if they grow larger. But this increased visibility comes from muscle hypertrophy, not from targeted fat removal. The body pulls fat based on overall energy demand, not based on which muscles are being worked. A common question is whether there is a best type of exercise for fat burning. The idea of a fat burning zone refers to exercising at a low intensity where fat makes up a larger percentage of the fuel being used. While this proportion is technically higher at low intensity, total calorie burn is low. For example, burning 100 calories at a low intensity where 70% comes from fat results in 70 calories burned from fat. But during a higher intensity session, you might burn 500 calories, even if only 30% comes from fat. That still results in 150 calories burned from fat, more than twice the amount burned during the low-intensity workout. So, while the proportion shifts, the total amount of fat burned depends more on the overall calories you expend. Different athletic activities demonstrate that there is no single superior method for fat loss. Runners, cyclists, basketball players, soccer players, tennis players, and weightlifters all train in different ways, yet none of these athletes typically carry excessive body fat. Their training intensities, durations, and styles vary dramatically, but the consistent factor is a sustained caloric expenditure. The lesson is that fat loss can be achieved through many forms of physical activity, and the best approach is the one a person enjoys enough to stick with consistently. Whether someone prefers long-distance running, high-intensity intervals, resistance training, recreational sports, or a combination of methods, each can be effective. The key is creating a sustained energy deficit, burning more calories than you consume. Fat loss is influenced by genetics, age, hormones, and lifestyle, but focusing on the variables we can control is essential. We can control our physical activity levels and our caloric intake. When the number of calories burned regularly exceeds the number of calories consumed, fat loss becomes possible. Over time, as adipocytes shrink and the fat layer decreases, the body becomes leaner, muscle definition increases, and overall metabolic health improves. Understanding these processes not only clarifies how fat leaves the body, but also empowers people to make informed decisions about their health and exercise habits.